Guys, so in this video we're going to talk about the second derivative test to classify the extrema of a function. So remember that extrema are going to occur when the first derivative of the function is either 0 or undefined. So the first step we're going to do to classify this extrema is finding the critical numbers or critical points. And to do that, we're going to find the first derivative, and we're going to find out when is this first derivative equal to 0 or when this first derivative will be undefined. These points, this is going to give us a set of points, say x0, x1, some points that are going to be critical. And what we're going to do then after is we're going to take the second derivative. Then the second derivative, we're going to evaluate it at those points we found on step 1. Why are we going to do this? Well, let's think about it for 1 second. Suppose that I have a critical point where, say critical point there where the derivative is 0. The slope of the tangent line is 0. And let's assume then that the function is concave down, like I drew here. So if the function is concave down, then you have a relative max at that critical point. So if your second derivative is negative, because concave down, if the second derivative is negative, then, well, would be at a point. Let me write down the point just to make it clear what we're talking about. So if the second derivative is negative at x0, then f has a relative max at x0. Because you would have that the first derivative is 0, that is a critical point, and then your second derivative is negative, telling you that it's concave down, therefore it's a relative max, which is kind of the opposite of what you would normally expect. You associate a relative max with positive and relative mean with negative, but it's quite the opposite for the second derivative. Now let's look at what happens when the function would be, say, concave up and have a relative extremum, sorry. What you would have is that if the second derivative is positive, that is if the function is concave up, at that critical point, then you have a relative mean. So I should say if then, but in that case then f has a relative mean at x0. And if the second derivative happened to be 0 as well, then your second derivative test will be inconclusive. So let's look at this example now in the light of this little explanation, and let's try to apply our second derivative test. So let's go ahead and follow the steps I outlined. So first step is finding the first derivative and setting it equal to 0. So our first derivative here, 3 multiplies negative a third, we get negative 1. X cubed, x to the power of 3 minus 1 is going to be x squared, plus 12x, and then minus 11. So that is our first derivative, and we're going to set it equal to 0. Let's do that down here. So let's say 0 equals x squared, and I'm going to change the signs. Basically what I'm doing there is multiplying times negative 1. The reason why I do that is because I prefer to factor things in this form where the leading coefficient is positive, but that's just a matter of personal taste. You could have factored this expression right here. Okay, so we factor and we get x minus 11 x times x minus 1. When you multiply negative 11 and negative 1, you get positive 11. And when you add negative 11 and negative 1, you get negative 12. So that is your factorization. And this expression, on the right hand side is equal to 0 only when each individual factor is equal to 0. That would be whenever x is equal to 11 or whenever x is equal to 1. So we have these are we're going to be our critical values, and these are the points where we have a possibility of having a relative mean or a relative max. Now, the other option would be if the first derivative does not exist or it's undefined, but this is a polynomial, so it's always going to be defined, so we don't have a problem with that. So then what we're going to do is find our second derivative. In this case, we get negative 2x plus 12, just the derivative of our first derivative, negative 2x, and here we get plus 12. And we are going to evaluate that second derivative at both critical points or critical values we found. So 1 and 11. So for x equals to 1, this would be 12 plus negative 2, which is going to be 10. Just plugging it into the second derivative. And then when we plug 11 here, we get negative 22 plus 12, negative 10. So this one is positive. Tells me there's a relative min at x equals 1. And this one is negative, so it tells me there's a relative max at x equals 11. And you could plug it into your original equation to find the x and y coordinates, to find the y coordinates. That would be done in the original equation. I will not do that just because of the function. We're going to end up with calculating thirds and things, so I will not do that. But you can certainly do that. So that is what we obtained. Let's look at x equals 1. We should have a relative mean. And you see how you have 1 right here. And sure enough, you have a relative mean right here. And at x equals 11, assuming I'm going to go in a vertical line, you have a relative max right here. Okay. And as I said, your the coordinates for this point, you would just plug 11 and f of 11, which would be your y coordinate. And so you see how the function is concave down here and concave up here. Now, a big danger, a big thing that happens when you're doing the second derivative test is, since the statement of the problem says use the second derivative to classify the extrema, often people do, and this is not right, but what often people will do is set the second derivative equal to 0. But this, what is going to give you is not critical values. It's going to give you possible inflection points. In this particular case, this would happen when you solve the equation negative 2x plus 12 equals 0, gives you x equals 6. This x equals 6 is not a min or a max. You can look in your graph, in the graph of your function, right here, x equals 6. All you calculated is this point of inflection where the function went from concave up to concave down. So this is point of inflection. So remember, do not set the second derivative equal to 0 when you're doing your second derivative test, because that's going to give you possible points of inflection, and that is not going to give you critical values or relative extrema. So when you're looking at min and max, it's always the first derivative equal to 0 or finding where it's not defined. If you do second derivative equal to 0, all you're going to get is points of inflection. So that's that for this video. I hope it's clear. If you have questions, please write them on the comments or attend the conference on Thursday.